Hello, this is Mr. Best. Welcome to homework questions 25 through 29. Question 25. Read the math notes box for this lesson which describes how to find the area and perimeter of a shape. Then examine the rectangle at the right. If the perimeter of this shape is 120 centimeters, which equation below represents this fact? Once we have selected the appropriate equation, we'll go ahead and solve for x. So when you go back and read the math notes box in this section 113, talks about the perimeter of a two-dimensional figure is the distance around its exterior on a flat surface. It is the total length of the boundary that encloses the interior region. So the perimeter means that we need to add up all of the sides of this rectangle. All right, there's a couple different ways we can look at doing that. The first way we could look at this is just to add up all the sides and rewrite this as 2x plus 5 plus 6x minus 1. I'm going to put these in parentheses so we can see each side. Plus 2x plus 5 plus 6x minus 1. So that could be one equation, but if you look at the four choices off to the left here, none of those represent the perimeter as 120. So now what? Well, if we understand the perimeter in terms of a rectangle, we have two sides that are 6x minus 1. So we could also rewrite this as 2 times the length of the rectangle plus 2 times the width of the rectangle, since there's two sides that are the same, is equal to 120. Now that will represent equation C. So now that we have the equation, we need to go ahead and solve for x as it states. So let's go ahead and solve for x. We can distribute the 2. That's 12x minus 2 plus 4x plus 10. And all I'm doing is taking this 2 and distributing inside the parentheses to each of those. So that's still equal to 120 as the perimeter. We can combine like terms. 12x plus 4x is 16x. Negative 2 plus 10 is plus 8. Now we can subtract 8 to both sides. 16x is equal to 112. Divide by 16, x is equal to 7. Question 26. Delilah drew 3 points on her paper. When she connects these points, must they form a triangle? Why or why not? Draw an example on your paper to support your reasoning. So once again, Delilah drew 3 points on her paper. When she connects these points, must they form a triangle? So every single time you draw 3 points, do they have to form a triangle? And then we need to draw an example on our paper to support whatever reasoning we decide or whatever answer we decide. So we can first start by just kind of drawing 3 points and seeing if when I connect them, are they always going to form a triangle? And so if you do this, it first appears that no matter where you put the points, that they're always going to form a triangle. But if we put all 3 points on the same line and you connect them, it doesn't form a triangle. So when she connects these 3 points, must they always form a triangle? Most of the time they will, but no, they will not always form a triangle. We have drawn an example to support our reasoning, and so we'll say no, that if the 3 points are on the same line, then it does not form a triangle. So once again, make sure you are answering the question, and we have set it down here, that no, it does not have to form a triangle if the 3 points are on the same line. And don't forget, once again, to draw your counter example here an example here to support our reasoning. Question 27. Copy the table below on your paper, complete it, and then write an equation that relates x and y. So the first thing that I wanted to do is rewrite the table so that the x values went in some type of order. So I just redid mine. I also noticed that on this, it has 11 as an x. That wasn't supposed to be 11. It's a 1. I think it shows up in your book as a 1. So that went right here, not the 11, but the 1. And so when I put them in order, I noticed that 1, 2, and 3, 1 was at negative 2, 2 was at negative 1, and 3 was at 0. So they all increased by a value of 1. So if that's the case, then I could also work the other way and go backwards, and then therefore that means this will be a -3, this one will be a -4, a -5, and then now the -5, I'm going to have to go back a couple of them. It looks like 3 spots, so then the -5 should be a -8. And so I'll go ahead and fill in the table the way it was ordered. But I just like to reorder mine because it helps me see things a little bit better. So it should look like that when you're done. It also wants us to not only complete the table, but then write an equation. So depending on how much you remember about writing equations and things like that, there's different ways that we could do this. But the first thing is that I notice is that the y-intercept is going to be at -3. So when x is 0, y is -3. I also recognize that my y values increased 1 as my x values increased 1. So therefore my equation would be y equals, my rate of change is 1, so that would be 1 times x. And then the y-intercept is at 0, -3. So this would be my equation. So once again, I kind of looked at the rate of change and then also where the y-intercept was. Question 28. Rebecca placed a transparent grid of square units over each of the shapes she was measuring below. Using her grid, determine the area of each shape. So as we look at part A, you can look at the number of squares that are completely filled in. So I'm looking at 1, 2, 3, 4, 5 across, and then I'd go 1, 2, 3, 4, 5, 6, 7. I think that's 7, 2, 4, 7. So if I fill all of these in, that would be 5 by 7. So that's 35 squares. So all of that. Make sure I don't recount any of those. Then I would move on to the next set here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So then I have another 15 total. So I'll try to color these in. And now the rest of them are just other pieces, but we're going to have to look at these where maybe we can match them up. For example, if I take these two down here, that makes one full square, so that's another additional one. Same thing happens over here, so that's 2 more. And then over here, it looks like I could take this square and add those up to get 1. Same thing happens here and here. And so there's another 1, so that's another 2. And then each of these are half, so that creates another 1. And then don't forget about this one up here. I think that's the only one I haven't got yet, and that represents a half. So if I add all those up, 35 and 15 would be 50, plus 2 plus 2 plus 1 would be 55, and then 0.5. So 55.5, and then this is just going to be square units, or units squared, because we're doing area. And that's just one way to look at it. But in the end, no matter what way you're looking at it, it appears to get up to 55.5 units squared. Alright, let's go ahead and do the same thing for B. So in this one I recognize 1, 2, 3, 4 across, and then 1, 2, 3, 4, 5, 6, 7 down. So that would be 4 by 7, and that is 28. So we have 28 square units to start us off. Color those in a little bit so I don't use them again. And then we can count the rest of them. Now on this one, it looks like, could we take this piece of the triangle, or actually go down a little bit further there to get to half. Could we take this and just swap this on this side to create a rectangle over there? Would that work? And then do the same thing with this one. Put that over here. And so we're going to take both of those sides and move them over here. And now we have this nice rectangle that is a 1, 2, and then 1, 2, 3, 4, 5, 6, 7. 2 by 7. So an additional 14 pieces, which would give us 42 units squared, or square units. And so that's, once again, one way that you can potentially look at that. And question 29. Evaluate each expression below if a is equal to -2 and b is 3. So we're going to look at three different problems here. We're just going to plug in the values for a and b and then evaluate. So a is -2. So therefore, since the a is being squared, then the -2 has to be squared, including the negative. Minus 5 times 3 plus 8. So order of operations, we do exponents first. Then we can do our multiplication and division. So that would be 12 minus 15 plus 8. And then addition and subtraction work left to right. -3 plus 8 is 5. On B, we have 2/3 times b, which is 3. So I'll do that 3/1. Minus 5 times -2. So 2/3 times 3 would be 6/3 or 2. And that's a -5 times a -2, so that's a positive 10. So 2 plus 10 is 12. On C, we have A, which is -2, plus 2 times B, or 2 times 3. That is all being divided by 4. And then you'll add 4 times A, or 4 times -2. So we need to do the numerator of the fraction, so that'd be -2 plus 6 divided by 4, plus 4 times -2. -2 plus 6 is 4, so we have 4 divided by 4, and that's 1, and then plus -8. So when we evaluate it, we get -7.